Did you know the key to unlocking the mysteries of our universe was launched into space on July 1st, 2023? Yes, I'm talking about the one-of-a-kind telescope, Euclid, which is on a mission to rewrite our understanding of the cosmos. Giants like NASA, CERN, and the ESA have come together to support this groundbreaking venture. By the end, you'll grasp why this is more than just a space mission. It's a journey into the heart of the unknown. But before we soar into the cosmos, we need to understand the elusive duo of dark matter and dark energy that have had scientists scratching their heads for ages. Getting to know them will help us understand why this Euclid mission is a big deal. Let's wind back to 1915, when Albert Einstein, with his iconic hair, flipped the scientific world upside down with his theory of relativity. He showed us that the planets don't simply wander around the sun aimlessly. Instead, they're following paths on an invisible cosmic fabric, twisted and stretched by the mass of celestial bodies. This radical idea sparked a whole new field of study, cosmology. Cosmologists try to solve mysteries like where the universe began and where it's headed. Einstein's theories acted like an adventurous guide, leading us to explore unknown regions of space and time. But guess what? We ran into a cosmic roadblock on this exciting journey. Two mysterious entities called dark matter and dark energy, which make up about 95% of our universe, showed up. Scientists, who seem to enjoy coming up with intriguing names, chose dark matter and dark energy for these elusive elements. It's not because they're fans of anything spooky or mysterious, but because these elements are actually dark and invisible, even to our telescopes. So, what have we found out about this dark matter? Well, to begin with, it's like the superglue of the cosmos. It keeps galaxies intact. Without dark matter, stars would be nothing but a chaotic mess scattered everywhere. Scientists have also been able to detect it. Sort of. You see, high concentrations of dark matter bend light passing nearby. It's like the universe's own optical illusion. But what dark matter isn't is just as interesting. It's not just clouds of normal matter without stars. It's not antimatter. And it's definitely not made up of black holes. Our best guess is that dark matter is likely an exotic particle that doesn't play by our normal rules. It's a rebel with a cosmic cause. Then there's dark energy, even more elusive and mystifying. Its effects are clear though. Thanks to Edward Hubble, we know that the universe is expanding, and more recent findings suggest that this expansion is accelerating. There are lots of theories about dark energy. Is it just a property of space spontaneously creating more of itself? Or maybe it's the result of virtual particles popping in and out of existence? Or maybe it's an unknown energy fluid or field that permeates the universe. But how do we make sense of all of this? How do we shine a light on this invisible landscape? This is where the Euclid mission comes in. This is no ordinary mission. Led by the European Space Agency, ESA, Euclid is the equivalent of a celestial CSI team. This isn't some Lone Ranger operation though. Nope, this is a globe-spanning collaboration, including the big shots at NASA, the International Euclid Consortium, and a host of others across the world. At the heart of this operation is the Euclid Space Telescope. Now, this isn't your ordinary telescope. This is a European-made marvel full of scientific instruments and an expensive payload module provided by Airbus Defence and Space. And what's even cooler is that the ESA's Operations Center in Darmstadt is at the helm, steering this fantastic mission. Now, let's zoom in a bit on the star of our show, Euclid. Try to picture a space telescope bravely zooming across the vast cosmos, taking peeks at billions of galaxies, some of which are a staggering 10 billion light years away, to create the most detailed 3D map of the whole universe. And by 3D, I really mean it. The third part isn't just space, it's time. This huge detailed map will let us see where matter, stuff that makes up space, is spread across very long distances. It will also show us how the universe has grown and changed over time. Euclid's discoveries will help scientists fine-tune what we know about gravity and figure out what these weird, hard-to-understand things are. To carry out this important task, Euclid is decked out with some impressive gear. It has a 1.2-meter telescope that sends images to two really advanced scientific tools. One is the Visible Instrument, or VIS, which takes super clean pictures of galaxies. The other is a near-infrared spectrometer and a photometer, or NISP, which looks at galaxies' infrared light that we can't see, and tells us how far away they are. Euclid is going to gather a mountain of data, so much that the ESA's antennas, their communication link with the spacecraft, had to be pumped up to manage the data overflow. Once Euclid beams back this treasure trove of data, a global powerhouse of brainiacs known as the Euclid Consortium will dive into it. This team is like the Science Olympics, boasting over 2,000 scientists from over 300 locations in Europe, the US, Canada, and Japan. Next on Euclid's itinerary over the following month, it's heading straight for a cool place in space known as the Sun-Earth Lagrange Point 2, where it will be able to hang out with its older brother, the James Webb Space Telescope. This point in space is a bit of a hike, about 1.5 million kilometers from Earth. That's 4 times the distance from Earth to the Moon. Now, this point is special because it's exactly opposite the Sun. It's kind of like a cosmic equilibrium point between the Sun and Earth's gravitational forces. Once Euclid gets to this point, it'll be maneuvered into orbit around it. From there, mission controllers will kickstart the process to verify all of Euclid's functions, check out the telescope, and finally flip the switch on those scientific instruments. You could think of this phase as a pre-game warm-up before the big match. And over the course of 6 years, yeah, you heard that right, 6 years, Euclid will survey 1/3 of the sky with unprecedented accuracy and sensitivity. It's the kind of comprehensive cosmic survey that would make even the Hubble telescope blush. With Euclid set to gather cosmic amounts of data, who's up to the monumental task of making sense of it all? Remember CERN, that juggernaut of particle physics, where they're zipping protons around and crunching data from millions of particle collisions per second? Well, they're joining forces with our friends from the Euclid mission. Now, for creating the 3D map we talked about, they need to handle a ton, and I mean a ton, of data. And that's where our heroes at CERN come in. CERN is deeply intertwined with Euclid's Science Ground Segment, SGS, the team responsible for processing and analyzing the Space Telescope's data and merging it with information from Earthbound telescopes. This superheroic alliance is striving to pry open the secrets of our enigmatic universe to expose the true natures of dark energy and dark matter. They're dealing with a mind-boggling 850 gigabits of compressed images every single day. But, as per our buddy, Luca Valenziano, who is the key player from the Euclid Consortium at CERN, they're up to the task. Given the complexity of the infrastructure and the pressure in analyzing the data as fast as possible, CERN's expertise is absolutely crucial. CERN's contribution isn't just on the tech front, it's deeply intertwined with the theoretical physics underlying the Euclid mission. Marko Simonovic, one of the bright minds at CERN's theoretical physics department, says that the exact properties of galaxy density fluctuations depend on the entire history of the universe. Cosmologists at CERN are working tirelessly, developing theoretical frameworks to predict these fluctuations, pushing the boundaries of our current understanding of cosmology and particle physics. And any new discovery in cosmology could potentially translate into a fresh revelation in particle physics. It's like getting a 2-for-1 deal on breakthroughs in understanding the universe. What secrets might we uncover in this tapestry of galaxies? As we marvel at the dawn of the Euclid mission and its potential for unearthing the universe's deepest secrets, let's not forget that there's already a universe full of surprises awaiting our attention. For instance, did you know that we found galaxies that, according to our current understanding of physics, simply shouldn't exist? If you're eager to dive into this astronomical anomaly, watch our video, Finding Galaxies That Shouldn't Exist. You'll uncover how these enigmatic galaxies challenge our cosmic theories, and why they could be key pieces in the grand puzzle that Euclid is setting out to solve. Who knows what astonishing truths we'll stumble upon.